minute for a quick introduction of myself, and then we can hop in the topic. I would like to have the conversation more discussion-based, so feel free to chime in to get a few things so we can have a more discussion conversation as well. And one more thing that my name is Kuen Lau. I am from TA Instruments. I'm starting from a material science background, a PhD in material science, and joining the TA for a couple of times. I'm starting looking on battery into the characterization technique for battery and battery material, including slurry to thermal analysis altogether. So maybe a quick introduction for what TA Instrument is. If some of you guys have not known us before, my topic will be focusing on batteries, successful batteries starting with slurry. So TA Instrument is a nickel solution company that has multiple product line that focusing on thermal analysis, rheology, physical thermal property, microcurrent, and physical testing. We're looking for a full material characterization technique that helping in the industry. And you may be asking how TA Instrument is helping, or what technology that we can help on the battery development. So we have multiple products specifically helping on battery and battery industry. One of the things is we inoperando microcurrent solution that helping customer to looking into battery R&D safety. And we'll do focus on, and also rheology technology that looking for helping customer to understand slurry, but not only slurry, but also mechanical testing of flow property from material, powder, to electrode. So this is the topic that I will be focusing more about today. And then next one will be, we also have product thermal analysis product to battery and battery material safety as well. So one quick question. So when you come into battery or electrode manufacturing actually is the highest important piece of the battery when you come in for fabrication of battery. And it has to be, a lot of people may be underestimating when you're putting the battery electrode together. They were thinking maybe they're putting active material, binder, slurry, unsolvent all together, and magically will come into formula electrode that has the right structure, right composition, but oftentimes that is not always the case. So it has to be a very important to understanding when you're putting from material is a unit formulating the slurry. A lot of characterization is required to understanding the solid content, the thixosopy, the stability of the slurry, and how it important on the coating process for making the suitable battery. And a lot of time, the material quality was very important, especially depends on your vendor basis. So I have a few things that I want to touch base with the team to get introduced a little bit more further. So one of the big thing is a lot of people might be in the manufacturing might be underestimate the importance of incoming material characterization. Really important formulation when you come to active material. People may be looking for XRD. And that's a lot about it, like XRD and crystallization strength, which has dictated the battery performance and capacity. But a lot of things that people may be underestimating how important are in the thermal stability of the binder cathode material. So this is example from LFP. Sometimes the cathode material maybe have some certain coating on it to helping the protection. Very important to understanding the structure, the composition, what type of coating, is the coating is uniform or binding. The phase transition of those was also important to related to your performance as well. And the other thing people might be underestimating is the binder. The binder has very important impact on it. So not just adhesive, but also that's a glass transition for the binder as well. For a lot of battery, when the glass transition has to be in below the operation battery temperature, the battery operation temperature, if it's this really rigid about the glass transition temperature, you're actually getting more flowable and you can actually controlling, allowing lithium going in and out into the cathode material. But if it's really rigid, your electrode material will be also really brittle as well. So it's very important. And one other thing that for PVDF or other type binder, there's a structure, melting temperature, how you're processing as anything, especially people looking on dry electrode, you want to understanding the melting temperature, if hot pressing, characterization of those. So those is very important to understanding the characterization of the incoming material. And the other thing that people may underestimating is the powder material. So active material binder or conductive additive oftentimes is coming in the powder form. Some people in the manufacturing step maybe undergo dry mixing, then probably problem in the powder agglomeration, slurry flowability if it's blocking in the piping for solid transfer. Very important to understanding the flowability, the powder flowability, the bulk flowability, flow energy, and also your compact material, the cohesion material of the material. Would they be more really willing to easier to adhere? So this is one of the example that we have it put in here is there's a two type of graphite material. You see that they're very different cohesion and really different yield strength. So cohesion will give you information on how easy of those particles will be agglomerating, sticking together. It really depends on some of the cohesion will be depends on the storic condition that those powder is keeping into. Sometimes the coating will be impacting the cohesion property. And the other area people will be needed to understand is yield stress. Yield strain is you can think about when you transporting a powder, how much force you need to put it in. If it's a really high yield strain, you need to have a larger force to push the powder flow, powder mixing. So it's very important on those areas. Another thing that is flowability and flow energy. One of the things when you're mixing into mixing tank, for pre-dry mixing, it's really important to understanding the flowability. There's a two type of flowability. We call it unconfined flow and confined flow. Unconfined flow is going to, when confined flow is you're actually compacting down and flowing downward. You will see there's a three type of formulation that we're showing here. You can see very, very different on the flowability of flow energy. And the flow energy also depends on the flow speed. So you think about like when you have a faster flow, you have higher shearing. It's very similar to slurry, but you need to understanding the powder characterization of those. And so we quickly go through what is important when before you putting in everything into the slurry. But one more, now I want to have a poll question with the group of people. We want to like to hear your feedback in the poll question that maybe we'll be creating a different type of formulation when you're making the slurry formulation. After that, you mixing all together, putting in the coating, and then understanding a drying process and calendaring and electrode. Which would be the most difficult, or you think would be the most critical part of the slurry? Do you think it's the formulation part would be more challenging or the mixing coating? Mixing, I see people mentioning mixing. Calendaring? How about other people? So I will walk down to a little bit more detail on which of the process is overall how is important. So a lot of the formulation, when you're formulating the slurry, people will be looking into viscosity. Viscosity is one big part of the slurry floating of the material. But viscosity oftentimes is not enough. A lot of people may be using a viscometer. How people is going to be understanding the viscosity actually will be change of a coating speed. Slurry is a very known to have a shear thinning behavior. What it means is the viscosity will be decreased with a high shear rate. So you need to understand the structural property of the slurry and understanding structural recovery, the stability, and also yield stress. So I will give a few examples here. But first of all, let's looking into more important thing, what will be changing your viscosity or the electrode performance at the end. Your formulation, how much of solvent solid content in the slurry will be really dictated the viscosity of the material. Your binder, active material, cathode and solvent content. Sometimes people may put dispersion into your material. Those is also impacting how well those material disperse in the slurry. Mixing, type of mixer that you're going to use, planar mixer, solid mixing, how you're making procedure. People do they pre-mixing, dry mixing of the material first. The procedure, the mixing time will be impacting on your ultimately this formulation, the slurry consistency. And then coating speed. One of the big things I will also talk a little bit later is when you coat and you high shear, and the slurry is actually under high shearing. Oftentimes that the structure breaking down, and that's a process called recovery. I will talk a little bit more detail on the recovery time will have a big impact on your slurry formula, like the post manufacturing. And drying, are you going to making sure that your drying profile, drying time, temperature. Even though in the iron work you calibrate those, how much compression force you're putting in down on the candering, what gap setting you put in will be also dictated on your electrode. You want to have your component distribute evenly and also have a good conductive pathway for electron to go through to your current collector. So everything is important to understanding step. And rheology will be helping you to understand a lot of understanding how the consistency of the material and how it cuts. As I mentioned, rheology, slurry is known to be a shear thinning property. So oftentimes when you're low shearing, it will be mimicking how the slurry stability. Oftentimes when you're going to, once you shearing, have an increasing shearing, you will actually going to see a reduction of the viscosity. So that when you looking, that's a very important information you can get. For in the low shearing region, you can understand your stability, your recovery region, what is viscosity will recover after recoiling. Medium ranges often give you information how mixing. You understand certain shear rate during the mixing regime. And high-speed coating, oftentimes you're going to ultra-high shearing. So you need to understanding when you're under high shearing regime, what the viscosity would be over those regions. And typical viscometer will give you a medium range, but you need to understanding the both low shearing and high shearing, helping you to dictating the process stability. In rheology for slurry or coating formulation, oftentimes that's one big thing that people will looking into important. We call thixosophy. It is time temperature dependent of the slurry behavior. And oftentimes there's a multiple way you can test a thixosophy, and the most common way we call it three-step thixosophy test. What it does is you're starting with low shear rate, you're understanding your viscosity measurement of your shearing with this formulated material, and then it will be oftentimes a structure network. And then you go down to low shear rate to shearing, thinning the material to understanding your destructive structure. And then you go back to low shearing to look at the structural recovery. There's a few things very important to utilize and test is if your shearing recovering time is too fast. You're imagining you're putting a painting on the wall. If the recovery time is really fast, you will see the straight mark. So same way with the coating machine. Once you're coating on it, it maybe have a defect that may not be leveling out. You maybe have an uneven coatingness on it with the somewhat we call leveling issue. And then if it's recovering too slow, you may be taking too long, and you may have a running edge or sagging impact on similar with the coating. Another criteria that you can actually understand in slurry much better is we call it thixosophy index. It is a ratio between your viscosity between a high shearing and low shearing regime. It is a way that you can actually quantify with the shear thinning behavior, and you can formulating by your shear monitoring or formulating based on how you're adjusting that ratio and to helping you understanding how well of the formulation that you will be creating. Is it that will be fitting for your coding machine. So we talk a little bit on the coding, shear coding, but oftentimes the coding is not enough. You get a good coding on the current collectors. Oftentimes that you have a poor electroconductive network or poor charging discharge function at the end. So that's oftentimes important to understanding the electro property of the shearing, because you have the network structure recovering, but also there's a conductive network. The conductive network, how it disperses in the slurry, how we recover it would be also very important. And we have some of the information can share with you guys with the real impedance data. So conductive network, people have been using carbon black. Some people and other new innovation trying to look in carbon nanotube to increasing the conductivity or reducing the material. So we know that increasing the conductive additive will be reducing the resistance. So you will have a better conductivity. But oftentimes when you're increasing those, you will actually increasing your viscosity and increasing yield stress. And go back to the three-step thixosophy testing. When you breaking down the slurry recovery, oftentimes the slurry recovery will be driven by your viscosity or active material, which is a larger component of your slurry formulation. Conductive additive oftentimes very minimal content, but the recovery of the conductive additive could be really scaling and breaking down, or could be really aggregating together, do not have a formulating a good conductive network. Ultimate goal you want to formulating the slurry is actually have a good conductive network of conductive additive to bring it to electron fast charging. We have some examples showing here that of two type of sample that looking for different type of concentration of carbon nanotube. One of the example of 2% carbon nanotube, we're seeing the formulation when you're going to go through spectroscopy testing, you will go back to recovery. The recovery very well into the structure. But some of the when you're going to higher carbon nanotube concentration, the recovery actually did not. Of course, you were seeing different into the resistance of the material itself. So the formulation will be different, but also you can see that the recovery also different. They did not go back to recovery for initial. So that's very important to understanding the recovery behavior. And this is a snapshot on the recovery step. You also need to understanding it's a time dependent that we showed earlier. The conductive network also have time dependent behavior that we can actually monitor in those with the real impedance. After shear breaking down, looking at the recovery, you can continue monitoring those. And you're picking for those, that's one example they're showing here. For the slurry after the recovery, you're seeing the viscosity recovery pretty rapidly, that maybe around 38 seconds, that also already get back to the original viscosity. However, the conductive network, which is we monitoring the reactant, it actually did not recover to what it was supposed to be until almost over a minute. So when you're thinking about when you're putting in your slurry coating, how long the distance between you getting a drying oven to lock in place, you need to understanding how much time that you have to lock in. If you lock in too early or lock in too late, you will changing the structure as well. So here's one example that we're showcasing. That's two different render of the carbon nanotube additive. As I mentioned, the slurry viscosity are very similar because it's driven by your active material binder material in your system. But when you come down to the real impedance, looking into the impedance property, you can see that there's a big change. For the first type of slurry, that you have a very consistent, did not impacting too much on slurry shear rate. The other slurry that you will actually have a really, really different on the resistance of the impedance characterization. You can see the changing of it actually rapidly changing, and you may see that the recovery may not be getting well as well. We're using the two type of slurry to formulating, drying them, and looking the SEM. We're seeing that the slurry, the electrode that formulate produced from the two different slurry is very different. One of them is more mesh conductive network. The other one is actually very bundle aggregating. Did not see a really nice conductive network. And reproducing, making a coin cell to actually evaluating those as a very, we're seeing differences. For low charging rate, low C rate, 1.1 C, it didn't see too much of difference on capacity loss, but it's very important when you come to fast charging, when a lot of battery formulation looking for increasing fast charging. Those conductive network is very, you can see a huge difference when your capacity loss from the second electrode actually drop off much faster compared to the one that have much more conductive network. So this is giving you an idea on when you're going to looking at slurry characterization. This is giving you information before you're locking paint drying together that maybe you don't have a good productive, you need to reducing to the actual rerunning the sample compared to previously. So it giving you some insight on how the formulation and also potentially increasing provide better yield for your production as well. So I got kind of giving a quick rundown on my presentation and going over to a lot of more characterization need on each of the category. So I'm also want to hear some of the feedback. So understanding how you guys using the viscosity testing right now. Do you using a viscometer, rheometer, or you also looking for something that inline online technology to help monitoring your slurry formulation? So I'm happy to hear some of the feedback. I'm holding up a quick poll. So you guys, if you want to getting
I have a quick question, and maybe this is a little, my understanding here is not as advanced as yours, but more on the recycling side. So when you shred the battery and you end up with that black mass, and that is in the incoming materials into the slurry, what sort of quality control would you have to do then? Would it just be the same as what you just explained?
for the black mass, I think one of the big thing that you would be also uh, want to actually starting to do is like, is similar to water powder. Now you have the black mass that uh, already in the powder form. So the powder formability, understanding how it process. The other thing that the black mass that you for the recycling, you will also probably want to you probably also want to know or getting information of the stability and composition of the black mass, because the black mass, you maybe have some binder on it. You also maybe have some of the material that into your characterization. So after your black mass, do you using a hydro or technique to understanding to recycling the material, and then you will be under some type of slurry condition. So the slurry viscosity also important to have you like how disperse or mixing, how you're going to process it, permeability. Those will be something that you might be we maybe need to consider. So powder rheology, I think, will be one big thing that, especially going through recycling and thermal composition, like material composition. Those is one area that you may be looking into.
Thank you.
So I just get the quick poll out. So what my previous asking, or what type of technology you're currently using for slurry, rheometer, viscometer, or some type of inline online technology. Happy to hear some of them. I think BJ, you have hands raised up, so you.
Yeah, thank you. I just was going to comment on your comments regarding rheology. So, my background is in slot die coating and primarily electrode manufacturing, and I do see a wide range of instruments used. Many do look at just using a viscometer, and like you, I feel that's not enough information. We really need to do a full rheology flow sweep to look at what that slurry rheology looks like. Slot die can only process what it's given. So, and slot dies have a fixed geometry. So, if that rheology is changing even by a small amount, it's going to impact the results coming out of the slot die, which go into drying and go into calendaring. And that contributes to the scrap rates and the low yields that the team has been talking about here this morning. So, my opinion, every line should have a rheometer and a full analytical lab to look at slurry rheology. In the poll, I did vote for online or inline measurement, in part because we're seeing continuous mixing become more the norm, going from batch to batch to continuous using a compounding extruder type mixer. And if you're going to do things in a continuous fashion, then you need to be measuring in a continuous, inline fashion as well. You don't have the time to draw samples and take them to an analytical lab.
That's a good feedback too. So for ideally, I imagine then you incorporating inline online testing in the equipment that you're working on.
Yeah. Oh, yeah. So that's the other thing. So when the poll question earlier about where would you spend $1 million, looking at in my background in electrode manufacturing, I would spend it in online measurement systems. So is it online rheology that you can gather, online density measurements? And I would look at, for the coating quality, online gauging systems, vision systems, X-ray systems, as much data as you can get on the electrode quality, starting with the slurry, the better. And then using that data to make educated process decisions. So you also have to couple that with, cloud data analytics and put it all together to be able to see things that you can't see individually. If you have data from the mixing room and data maybe from the coding group and then data from the calendaring team, if it's not all connected to be able to draw good conclusions, then it's kind of useless, because everybody
Yeah,
can control what they can control, but they don't really see upstream or downstream. So I think it all has to be tied together into one data set.
that's what we think is important too. So let's share. I share the poll result that we just got. So I think it's good that people are looking for rheometer already, but it seems like a trend is looking into some of the inline online technology that can helping the group. Anyone has already implementing some of the inline online technology in in the manufacturing floor. I know that's I think BJ was mentioning the technology is we're looking for with a 1 million. We'll be betting on investing on the looking for new technology for inline online monitoring. I'm curious, is anyone actually doing some of the.
I have not seen it prevalent. Again, going back to some of the groups that are working on continuous mixing, they're looking at some inline measurement systems to better quantify what they're producing. And there is an intermediate step there. Even if you're doing continuous mixing, you're not going to do continuous mixing directly into a slot die coder. There will have to be some buffer tank that's in between there to be able to handle a process upset in either direction. So if you're continuous mixing, maybe your powder feeding system goes down for some reason, you have a capacity of a buffer that you can continue to coat on the coating line, or vice versa. If the coating line has a web break or something, you're not slowing down the mixing system. But I think in the end, as we talk about machine learning and all the AI and the data analytics that are coming online, I think the inline online measurement is going to be a bigger and play a more important role.
Yep. I think that will be a big step on the next step too for understanding what is the slurry manufacturing. So one of the questions that I think in the poll earlier, they're mentioning how many people will be looking in the performance and the manufacturing yield. So it seems like a big topic was trying to like half and half split. I'm also want to get another poll from the audience to. This is the earlier one. Sorry. Yep. Go back. I want to actually. Want to hear the audience about what other topic that will be important, and also what topic for the group to actually want to learn more. I think this is the target. Topic was sorry about that. That was the topic. The title wasn't correct. So want to hear the audience to big group to see what topic that you would like to learn more about. I think manufacturing, slurry, characterization, one of the big thing that we talk about on the manufacturing side. But anyone want to like thermal analysis for new chemistry performance, slurry powder rheology, particularly for dry electrode processing, and also mechanical analysis and battery material for next generation for solid state. A lot of time that need to be applied pressure, how the material performance on those high pressure, and also battery screening and cell selection. Or you want to understand more on the battery pack material and integration. So want to hear the group what will you be preferring on trying to learn more. I'm also interested in some of the background from the audience too, because I know BJ is mentioning your coding company, so looking for rheology is a big part of it. I think Tina mentioning she was on recycling, material recycling for what type of characterization. So what type of background for other audience? We're closing the poll shortly and share the result with everyone. So I see most people would like it's kind of split, pretty divided. So people looking for thermal analysis, also slurry rheology, powder rheology, and also battery selection and cell selection. So we can also create some of the topic with the audience as well. Would also like to share with you guys on the content that we have on as a really short time, so I want to be a little bit more conversational. But I also want to share a few some information for the website that we do have application note topic. If you're interested into the technology or the rheology or the impedance, we can happy to share or talk to more people as well. So I share the link to our webpage. So you can also roll down to the webpage. We have a contact form and down below, if you want to hear more or talk to our scientists to learn more information about the slurry rheology or the technology, and also some of the mechanical testing, thermal analysis, we can happy to share as well. So I think the major group was from to 1 o'clock, so I am happy to stay longer if you guys have any question or any interest topic that the team want to discuss more about. So I hope I can share the team that important to understanding on all the characterization need from incoming material all the way to slurry characterization to mechanical testing, and at the end